So then we come down here to this problem. One thing I want to show you with subtraction is that there's three basic methods for subtraction. And the first method is that you decompose a unit of a higher value and combine before subtracting. This is what happens in the traditional algorithm. So one of the things we want kids to recognize when they look at a number like 84 and they want to subtract 18 from it, that they recognize they've got plenty of ones to work with. We've done all of this work with place values, so they recognize they actually have 84 ones sitting there. And so some of their place value tools will help them really see that nicely. Like when I look at this picture, I can easily see in here all the ones that are hiding within my tens. And so if I were just to give you 84 sticks and ask you to subtract 18, there's really no regrouping or no work because you just take away 18 from 84. It's really easy to do. When we look at things in bundles a little bit more carefully, then we start to recognize the need to think around what we're doing here. So if I've got 84 and I want to subtract 18 from this, what I can do here is say, well, all I have to do is take one of these tens and split it apart. So I'm going to take one of these guys over here and I'm going to split it apart. So I'm just going to kind of show that this one's being used. I'm going to bring it back over here. Before I was bringing things to the other side, and now I'm just going to bring this over here. And so what I'm going to do is I'm just going to show this broken apart. And so what I have is 10 loose ones over here. And so the traditional algorithm has kids thinking about this as a 14. Okay, and so now I've got 14 ones that I can subtract 8 ones from quite easily. So I'm doing this problem, 14, and I'm subtracting 8. Okay, and so when I do 14 subtract 8, this is why all of your subtraction within 20 is so important, because every time you decompose a unit of a higher value in subtraction problems, whether it's in your ones place, your tens place, hundreds place, wherever, you're creating problems within 20 that the students need to be able to subtract. So having fluency within 20 is really important, because now I can do 14 minus 8 and recognize that I'm going to have 6. Okay, so I could even show that in my problem. I can show myself, there's the 4, then another 4 that I'm taking off there. So you can see that I have 6 left over. Then over here, I've taken away this one 10 already, and then I'm going to take away another 10 because I'm subtracting another 10 there, so I'm left with 66 as my final answer. So another way of looking at these problems is, if I were to come down here, okay, you can also, when we're doing this decomposition, is to subtract first and then combine. Because remember, I have some different ways to view this. So, so rather than subtracting the 14, subtracting from the 14, I can subtract from 10 and then look at what I have left over. Because this is another relationship that we've been working extensively with kids to understand all your subtraction facts within 10. So when I come down here, I'll show you an example of how this could look. So basically what I'm doing is I'm saying I've got 84 and I'm splitting it apart into, so if I have 70 over here, I've split out my 10. Rather than combining it with a 4, I can leave it separate. So now when I want to do my subtraction, I can come over here and say, well, I can subtract the 8 from the 10. That's really easy to do. I get 2. And then I can come over here and I can say, oh, well, I can subtract a 10 from my 70, and I get 60. And then if you look at what's left over in my number bond here, you can see my 66 that I have from the last problem. So it's the same thing, but it just goes back to another fact that they have a lot of fluency around, which are all your subtraction within tens. So when I come down here, I can do the same thing with my dollar bills or my $10 bills and different things like that. I've got 84, and actually with money it makes a lot of sense because that's probably how you'd be thinking about it, and it's easy to do that problem. So if I want to subtract the 4 ones, if I just think about my 10, and I pull this down here, and I think about, well, what would 10, and I subtract 8 ones from that 10, what would my change be? Well, it's easy to think about that. That would be $2 left over. And I had the $4 over here, so this gives me the, so I'm really just doing the subtracting from the 10. And so I have 6 left over when I put these guys together. So they're 4 and then there's 2. And then over here, then I can easily subtract another 10 from 10. And you can see that I'm left with 66. So if I could actually physically move those on the counter and actually write down the problem that I'm doing next to it, that's an easy way to track your work there. So coming back to the number line again, the third method is actually looking at the subtrahend and thinking, so that's my bottom number, and sub is below. So subtrahend is what I'm taking away from the number. So if I start at 84, I can break that 18 up into pieces to make it easier to subtract. And whenever I think about that, strategies around subtracting, it often makes me think about the number bonds and makes me think about the open number line. So that would be an easy tool to use when you want to show this, so that if I'm at 84, I can say, well, what could I break my 18 at to make it easy to subtract? And so what I might want to recognize is that if I break it up into, so for example, I could break it up into these pieces. Actually, I'm going to break it up into 3 pieces. Okay. So what I'm thinking is if I could jump back 4, subtract my 4 here, I'm going to come backwards that way. And when I come back 4, I'm going to land on 84. Sorry, from 84, I'm going to land on 80. And so now I've subtracted my 4. Now I can easily subtract 10. So as I'm subtracting, I'm moving to the left here. And I'm going to land on 70. Okay, and then I have to also now subtract 4 more from 70, so then that's going to cause me to jump down another 4 more, and that takes me to 966. Okay. So this, obviously you might have different strategies about how you break this apart, but the number line lets us break it apart into pieces, and the number bond also lets us do that. So we can strategically break apart the pieces that we're taking off to make it a little easier to think about. So that's, so for example, and so if kids get good at, the hardest part here is probably the 6 to 70 minus 64, so knowing how to break across that, into the next 10 is probably the hardest move that you'll see in some of these problems. And then also, we mentioned in the standards that the relationship between addition and subtraction is another important concept that we're getting out of 2nd grade. So the open number line is also helpful for this, because I could recognize that if I'm wanting to subtract from 200, so I'm starting at 246, and I want to subtract from that, and I want to subtract the 169, and I'm trying to figure out where that's going to leave me on my number line. Another way to think about this is to think about, okay, so what do I need to, so the other way to think about this is the related addition problem here. So I could say, what do I need to add to 169 to get up to 243? So really what we're looking at is this piece that we have over here. We're wondering, because this is really a length, it's not just a point, it's the length from 0 up to this. So what is this amount that I need to add up to the 169 to land on the 246? So that's another way of viewing this problem. So if I were to start with 169, so I could also take my number line and go the other way. So I can start at 169 and think about counting up to 246. How would I get there? And so this would lead into some things like thinking of, if I get to my next 10, it would take me up to 170. And then I could jump up to, for example, I could jump up another 100 if I wanted to. And that would be too far, so you could say, well, let's break this up and go a little bit not as far. So say if I wanted just to get up to 200, I would need to add 30. So kids can play around with this, and so if you did jump beyond, you can come back. But we'll get up to 200 here. And now from here, I could say, oh, this is really easy. I can just add 240. I could just add the 46 to this. And now I'm at 246. And if I look at the total amount I jumped, I can see that I jumped up 77. So this is another way of viewing this. I'm sorry, for my messy work, but you can get the kids to recognize the relationship between addition and subtraction, seeing those pieces on the number line and seeing that I'm really combining these two lengths of the mystery amount and the amount that I'm subtracting to get to that final, or to get to that 246 is another way of viewing it, rather than counting backwards from 246 or jumping backwards from 246. So hopefully this gives you a few ideas. I'd welcome other ideas or other suggestions that you have and what's working with your kids, and I will send around this file too, so if you want to be able to use some of the different ideas, manipulative ideas on your smartboard, you can use that as well. So good luck, and keep me posted as to how everything is going. Thanks. Bye.